Hello friends, welcome to the course Foundations of R Software, and you can recall that in the last two lectures we have been talking about the matrix operations. So now in this lecture also we will continue with similar type of matrix operation which are very simple, very elementary but very useful. So now once you have learned how to define a matrix, then first question comes that sometime you are interested in extracting a part of the matrix. That can be a particular row or a particular column or a submatrix or certain elements. So the question is how to get it done. And after that there are several mathematical operations, like as when you try to add, subtract, multiply a matrix by some scalar, or when you are trying to add, subtract, multiply some matrices, etc. These are various types of operations which are possible in the matrix theory and which can be very easily done in the R software. So now in this lecture we are going to learn that how you can access some elements in the matrix like as rows, column or a submatrix, and we will begin our discussion on some basic elementary operations in the matrix theory. One thing I would like to request you, that when we are trying to deal with matrix theory, then matrix theory has some different type of mathematical rules than the addition, subtraction, etc. of say scalars and data vectors. So I am assuming that you all have a good knowledge of matrix theory in the sense that you know all the rules of mathematical operations. So with this assumption I begin this lecture now. So I will try to take here some examples, and through that I will try to illustrate to you how these operations can be done in the R software. So let me try to create here a matrix of order 5 by 3. That means there are 5 rows which are defined by the parameter n row. There are 3 columns which are defined by the parameter n col. The data is arranged row wise, and data is here 1 to 15. Why? Because there are 5 rows and 3 columns, so you need here 15 values. So I am simply trying to give here the data is 1, 2, 3 up to 15. Okay, and if you try to create this matrix will come like this. Okay, now we are interested in knowing that how I can access a particular row, particular column or a submatrix. So you can see here these are our rows and these are our first, second and third columns. Now you know. So now suppose I want to access a row. Suppose I want to access the third row. So for that the syntax here is you try to write down the name of the matrix X, then write the square bracket, and then in case if you want to access a particular row, try to write down here the row number and then write comma. On the other hand, in case if you want to access a particular column, then you write the name of the matrix and square bracket, write a comma and then write down the column number. That is the way we can access it. So for example, in case if you want to access here the third row of this matrix X, then you can write down here X, then square brackets and then 3 and then comma, and after that you do not have to write anything, you can just leave it as a blank, and this will give you here the value 7, 8, 9, and if you try to see here, this is here the third row. And similarly, in case if you want to access the second column, then you have to write down here the name of the matrix X and then square brackets, then just write comma, and before that you have to leave it blank, and after write the column number, say here 2. So you get here the values 2, 5, 8, 11, 14. So now if you try to see here in this matrix, this is your here column number 2, 2, 5, 8, 11, 14. So now you can store these values in a particular column, in a particular say this variable, and use it further, and you can access any particular column, any particular row with these commands. Similarly, in case if you want to access a particular section of this matrix, suppose I want to have a submatrix in which I want to consider the fourth and fifth rows and second and third columns. So, I can write down exactly in the same way. I try to write down here the matrix name, then square brackets, and then information about rows and then information about columns, and they have to be separated by the comma. For example, if you want to have a submatrix from this matrix consisting of fourth and fifth row and second and third column. So, I can give it in this way. The rows are defined by here 4:5 and columns are defined as 2:3. So, now you can see here, this is here the outcome, and if you try to see here what are these things, what are fourth, fifth rows and second, third column, these are your here fourth, fifth rows, and this is here second, third column. So, this is your here intersection 11, 12, 14 and 15, and this is here the outcome. So, you yourself can just verify it by doing it in the R console. So, that is how we can know these values. Okay. Now, similarly, in case if you want to access any particular rows and columns, for example, here I have taken rows which are fourth and fifth, they are in continuation, and columns second and third which are in continuation. But suppose if you want to have a submatrix in which you want to choose the elements which are available in the first row, fourth row and first column and third column. So, it is very simple once you understand the basic fundamental, that first you have to write down the name of the matrix, then a square bracket, and then information about rows and information about. Now, you are giving here only the row numbers, these are your here row numbers, and these are your here C13 is your here column. And now, you know that how to inform R that you do not want to read only the one value, but you want to read all the values in the data vector. So, now if you try to see here, if you try to look into your here R matrix here, then if you try to choose here these many columns, well, I can remove it here so that you can see it more clearly. So, if you try to see here, the first row is this, and then you have taken here fourth row. So, you can see here, this is your here fourth row, and now you have taken here which columns? 1 and 3. So, you try to take it here column number 1 and here say column number 3. And now, you try to see what are the elements on their intersection 1, 3, 10 and 12, and you can verify here, are they coming here? Yes, they are coming here like this. So, now you can see here, this is how you can access any part of the matrix by these operations. Before I try to show you these operations on the R console, let me try to show you here something. Suppose I hide, suppose if you try to look at this outcome of the R software, a screenshot, and suppose I hide this part and this part. So, you can see here, this is for about the row and the second one is about the column, but I try to hide it here like this. And now, I give you only this outcome, this and this. Now, by looking at these two outcomes, can you get this information whether these two outcomes are corresponding to any row or any column? If I hide this thing also, then by looking at these two values 7, 8, 9 and 2, 5, 8, 11, 14, can you tell me whether these are the values from a particular row or a particular column, or which row or which column? So, that is the question which I am trying to answer here, that in case if you try to look at this matrix and if you try to have only look at this outcome, can you really tell me whether this is row or column? No, you cannot tell. The reason why I am trying to inform you here is that because in some software, when you write to try to write down a particular row or column, they also give you that information. So, by looking at the outcome here, which is written here like inside the bracket 1, we can also know in those software that whether this particular value is coming from a row or a column. So, that is the thing which you have to keep in mind when you are trying to do these operations in the R software. right. So, let us try to do these operations in the R software and try to understand how these things are happening. So, let me try to create this matrix. You can see here that this is the matrix here X. Now, in case if I want to access here third row and third column. Now, as a student, there is always a confusion when I want to write down the third row, whether I have to write like this or I have to write like this. This is always a very common confusion among the students, that when they want to access the third row or third column, which one of them is the correct option. So, I am telling you very simple option. If you try to see here, this is here third row, and in which they have written here as a bracket 3 and comma, and when it is here third column, they are writing here as say bracket comma and 3. So, whatever you want to know, you just try to look at this address and try to write down here X, right. So, for example, if you try to see here, this will give you here, this here is like blank and 3. So, this is here this third column, and if you want to find here the third row, so you can write down here like this. You can see here this is here like this, right. And similarly, if I try to say here this is your matrix X and you want to have here some matrix from 1 to 2 and 4 to 5. You want first and second row and fourth and fifth column, and then you try to see there is an error here. Why? Because if you try to see, when you are trying to write down here 4:5, that means fourth and fifth columns, there is no fifth column, there is no fourth column, there is fourth row and fifth row, right. So, it is why, that is why it is giving you as an error, and it is saying the subscripts out of bound. So, rather in case if you try to write down here a submatrix in which you want fourth and fifth rows and first and second columns, this will give you this matrix. Fourth and fifth rows, they are here, and then first and second column, they are here. So, this 10, 11 and 13, 14, this will give you here this matrix. And similarly, in case if you want to choose some arbitrary rows which are not in continuation, you can use here the C command and say here 2 and here 3, and what about here this column, say here 1 and here 2. So, you can see here 4, 5 and here 7, 8. These are the 4 values which will come here. So, that is how you can access any of this rows, columns or any submatrix from this matrix X. Right. Okay. So, now we try to consider here some more operations, some more options, and now we come to some mathematical operations, and we are now first going to consider that when we are trying a scalar, we are trying to conduct a mathematical operation related to a scalar and a matrix. So, suppose I want to know what will happen to a matrix when a scalar is added. So, you know the rule is very simple, that the element is added in all the elements, that is from the matrix theory. So, if you try to consider here a matrix here like this, X is equal to matrix with 4 rows, 2 columns and the data from 1 to 8, and the data is arranged by row, then you have here this matrix. And now, if you try to add here 5 here, then what will happen? That each of the element will be added with 5 like this, and this is here the outcome. So, similarly, when you try to subtract some scalar from a matrix, then the similar operation, that as in addition the number was added, in subtraction the number will be subtracted. Suppose if I try to consider the same matrix here X and I try to subtract the matrix by 5. So, what will happen here? That means every element will be subtracted by 5 like this, right, and you can see here this is here the outcome. So, this is how actually R works when the scalars are added and subtracted in a matrix. And similarly, if you try to multiply, then similar to that, it is happened when you are trying to add and subtract a scalar in a matrix. Similarly, when you try to multiply a matrix by a scalar, then every element is multiplied by the same scalar. For example, if you try to here take the same matrix and then I am trying to multiply it by here 5. So, every element in this matrix is going to be multiplied by 5 like this, and this is here the outcome you can see here. So, that is pretty simple, straightforward, without any problem. And similarly, if you try to divide a matrix by scalar, remember one thing, that I am not talking of the division of a matrix by a matrix because that is absurd, that does not exist, but I am simply saying that you are trying to make an operation here where you are trying to divide a matrix by a scalar in the R software. Then what R does? So, if I try to take here the same matrix which we have considered earlier, and now I try to divide this matrix by 2. So, now what will happen? Every element in this matrix X will be divided by 2 like this. So, and this is here the operation, you can see here, you can verify here. So, that is not difficult at all, right. So, before I try to move with the operation between matrices, let me try to show you these operations on the R console also. So, let us try to take this matrix here like this, and suppose I try to add this matrix with here 10. So, you can see here every element in this matrix has been added by 10, and in case if I try to subtract every element by 10, then this is your here X, and X minus 10 here is like this, you can see here. Yes, 1 minus 10, 3 minus 10 and so on. And similarly, if I try to multiply this value by here 5, that means every element in the matrix X is going to be multiplied by 5. You can see here like this, every element is multiplied by 5 here. And similarly, if I try to take the same matrix and divide every element by here, suppose 2, then you can see here each of this element is divided by here 2, and this is here the outcome. So, you can see here that these operations are pretty simple and straightforward, and they are not difficult to understand, but you have to understand that when you are trying to work with a matrix and a scalar, then what R is trying to do. Now, after this I come to a very simple aspect of addition and subtraction of matrices. That means, now I am trying to take two matrices, and I would like to see how R does the addition and subtraction. Now, remember one thing, when we are trying to do the matrix addition and subtraction, that means two matrices are added and two matrices are subtracted, then this is done following the rules of matrix theory, in which when two matrices are added, then both the matrices should have the orders. That means the number of rows and columns in both the matrix should be the same. And that is the same thing when you are trying to subtract two matrices. That is the first condition, that both the matrix should have same numbers of rows and columns, number one. After this, the addition or subtraction, that becomes element wise. That means the element of a particular addresses, that means if you try to say some element of matrix 1 and another element of the matrix 2 which is located at the same address as of the first matrix, they are going to be added or subtracted together, right. So, in order to do such matrix operations in R, let us try to consider two matrices, and then we try to see how do they operate. So, I try to define here two matrices here X and Y, which are 4 by 2 matrices. That means they are having 4 number of rows and 2 numbers of columns, and data here is in the first matrix is from 1 to 8, and in the second matrix the data is from 11 to 18, and in both the matrix the data is arranged by rows. So, now this is your here X and this is your here Y. You can see 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18. Now, I try to add it here. So, now what will happen here? If you try to look here, the addition or subtraction, this element which is at the first row and first column, this will be operated with the first row and first column element in the Y. So, these two are going to be operated. Similarly, if you try to take any other, suppose this element which is in the third row and second column in X, and the same element in the third row and second column in Y, they will be operated, and similarly all the corresponding addresses are going to be operated. So, if you try to say to add it here, then 1 and 11 are going to be added as 12, and if you try to subtract 1 minus 11, that is minus 10 is going to be there. So, that is what happened, and if you try to see here that this is your here X, this is your here Y. If you try to add X plus Y, this comes here 1 plus 11 which is here 12, similarly here 2 plus 12 which is here 14 and so on, and this is here the outcome. And similarly, if you try to subtract them, the same operation happens here, and the corresponding elements at the same addresses in the two matrices X and Y, they are subtracted. For example, if you try to taken this matrix itself. For example, if I try to take here this element which is on the third row and second column, that is going to be subtracted with the element on the third row and second column of the y matrix. So, this will become here 6 minus 16, which is actually here minus 10, and this minus 10 is here, right. So, similarly you can see here such an operation here. So, in this case all the values are coming out to be here minus 10, because you see 1 minus this 11, this is here minus 10, 2 minus 12, this is going to be here minus 10, and so on. So, do not get surprised. But now let me try to show you these things on the R console, so that you get here more confidence that these things are possible to do. So, let me try to choose here these two matrices x and y. This is your here x and this is your here y. So, you can see that here both of them are of the same order. So, now in case if you try to add them x plus y, and if you try to subtract them x minus y, it comes here like this. So, now and I hope that you know that the two matrices are added by the same symbol plus and two matrices are subtracted by the same symbol minus. So, there is no issue. So, now we come to an end to this lecture, and you have seen that we have learned once again here very elementary basic operations in the R software, but I can promise you these are very important, that whenever you are trying to deal with this matrix and theory operations in the R, then this accessing a particular row, particular column, or drawing a submatrix, or extracting a submatrix from the bigger matrix, or means multiplying a scalar with a matrix, adding a scalar in a matrix, etc. These operations are very useful, and more so for you it is more important that what R is trying to do. Once again I will say, I will emphasize on that, because the way R is going to work, if you understand that thing, then you can modify your programming in a much better way. So, now once again you have some homework to do today. Try to take some matrices of your choice and try to play with them. For example, I will say, if you want to see whether if the two matrices are of different orders, then how do they subtract or add. Try to take two different matrices x and y of different orders and try to see whether do they add or subtract or not, and try to verify what does this matrix theory tells you. Matrix theory says, okay, unless and until you have two matrices of the same order, you cannot add or subtract them. Try to see whether R is following the same thing or not. So, you try to play with R software with this matrix operation, and I will try to see you in the next lecture with more matrix operations. Till then, goodbye.